Okay, so now we want to flip it the other way around. So now we know how to go from giving you a component, right, the algebraic version of it, and find the magnitude and the direction of a vector. Now we want to go the other way around. And in fact, going the other way around is actually more important, it comes up a lot in physics that we need to do it that way, right? So let's switch this around. So first, now let's say we're actually given a magnitude and a direction, and we want to find the X and Y components, right? The X and Y components. So let's make that more concrete, right? So if I say, let's pick our little vector before A that has 5 units and sort of 30 degrees above the positive x-axis, right? And now, can you find me? Right, the question is what's the x component and y component of A? So it is essentially what's AX, what's AY, right? Remember, you can write it as however many components in the x direction and however many units in the y direction, right? Or AX, AY, like this. So how many x, how many y? Okay, again, it's nothing complicated other than you need to know your right angle triangles. So if you know how right angle triangle works, it's fine. So let's draw this out, right? So if I draw some dotted lines over here to match up sort of the projected down to the x and y axis like this, we can spot, for example, we'll look at this right angle triangle over here. So let's see. So this length over here is exactly AX, and this is exactly AY, right? So it's how many units in the x direction and how many units in the y direction, right? So these are our goals that we want to find from these two numbers. Okay, so remember, this is a right angle triangle, so all you need to do is know your sines and cosines, right? Sine, cosine, tangents, right? So let's say this is theta, right? So let's do sine of 30 degrees would be AY, so opposite over a hypotenuse. So that would be AY over 5, right? And what does that mean? So that means that AY is 5 times sine 30 degrees. Okay. Let's look at cosine of this guy as well. So cosine of 30 degrees is the adjacent, which is AX over the hypotenuse over 5, right? So that means, okay, this symbol in math means implies, right? So this implies that AX is, if I multiply over, is 5 times cosine 30 degrees. So all I have to do is plug in to a calculator and it's that simple, right? So sine of 30 degrees, you can plug in a calculator, or some of you might know it as 1/2. It's exactly 1/2. It's one of the famous numbers, and it's good to keep it in mind if you use it a lot, right? So it's 5 times 1/2. You can check that with your calculator right now, and you should get 2.5, right? So let's check it if I got it the same thing as your calculator. If you don't get this in your calculator, check that your calculator is in the degrees mode, okay, not radians or something else. All right, and then you plug this in the calculator, and cosine of 30 degrees is actually square root of 3 over 2, another number that is less easy to remember, but also quite famous. But you can check that with a calculator in an exam. You can, of course, use a calculator. So plug that in, and that should give you, if my notes is correct, 4.33. Okay, I didn't do that in my head, but yeah. And believe it or not, you're done. You found AX and AY. All that's left is you want to write it out nicely, right? So it's, which is my X, that's my X. So it's 4.33 I hat plus 2.5 J hat, like that. And you're done, right? So you got from the geometric view where you have the magnitude and the direction, and now you found both components. Now, this is, oh yeah, also I like to write in a column form like this. It's just kind of nicer in my opinion. Either way works. This process of going from this way to this way is so important. There's actually a name for it. This is called resolving vectors. this process, okay, this process of going from geometric to algebraic is called resolving vectors, okay? And we'll do a lot of them as we go on. So it's good to, as we go on in physics, we'll do a lot of resolving vectors. So it's good to familiarize yourself with this procedure. So let me give you one more example before we call it a day. Right, so let's try another one. Let's try one pointing in a different quadrant, right? So let's have one pointing actually this way. Again, we'll use an easy angle. We'll use 30 degrees this way, right? So you can call this theta, right? Sometimes you can give it a name, theta, like this. And this is it has a magnitude of 12. So let's say it has a magnitude of 12 units, and the direction is 30 degrees above the negative x-axis. Okay. As you can see, all three pieces of information, I've defined it, right? Okay, so step number one, as always, draw a diagram, draw this out, right? Sometimes you're not given this and you're just told the magnitude and direction. So I'll even write it out, right? So take a note of that. First step, always sketch the vector. Very, very helpful, all right? So once you've done it, right? So draw out the x and y. So let's call this b this time, right? Like this, and we have we know that the length, right, the magnitude is 12. Okay, so what's the bx? So this time this is bx, and this is by, right? So it's this many units, and we always start from the origin, right? So you're going this way this time, and you're going upwards this time. Okay, so this is bx. How many sort of x units and how many y units you go up, right? So now you can form your relationships. For example, by, right? By should be sine, or I should say, sine theta, right? Is opposite over of hypotenuse. So that's by over 12. So that's a subscript, and that means that implies by is 12 times sine theta, which in our case is 30 degrees, right? So that is, again, that's 1/2. I remember that. So that's 12 times 1/2, and that's 6, right? So that's by. I'm halfway done. Remember, I just need to find both the x and the y component. That's my goal, right? I want to find these guys, right? So if I'm halfway done, how about bx? Well, let's use cosine, because then I'll have adjacent over that. So cosine theta is bx over 12. And bx is equals to, because that's what we want to solve, right? 12 times cosine, in our case, 30 degrees again, right? So if you can plug that in your calculator right now and see if you get the same thing as I did, and double check, right? So if I trust the math over here, I should get 10.4. Okay, so don't stop here. Repeat. So if the question tells you to write out the algebraic view, then write it out properly. But be careful over here, right? What I've calculated is just the length over here, and you need to see that this is going towards the left, not right. Because if I write it like this, if I write bx is 10.4 and by is 6, that suggests I'm going to the right by 10.4 units, right? If I write this. So what I need is look at the diagram. So it's very, very important to have a diagram and sketch your vector so that you know to put a minus sign over here, okay? So that's the correct answer over here, even though in the pure geometry, that's the number you get, okay? So you can write it this way. You can write it minus 10.4 and 6. You can write it as a row. You can write it as the original full-on component form. Either way you write it, make sure it's in the negative direction. But y is fine. Y is going in the positive direction, right? So now you can imagine if you have a vector that is pointing this way, then the x would be positive, but the y would be negative. And if you have a vector pointing this way, you can fill in the blanks how that would work. Okay. All right. So in the next video, I'll show you actually a slightly quick trick. In principle, you can call it a day and cut right here and build this up. But in the next video, I'll show you a quick trick where if you're given this picture, because this process is you have to do it over and over again, right? It's annoying to do almost like 3 or 4 steps to get to this. So I'll show you a trick where in 2 steps, you'll immediately get the answer, right? So you don't need to set this up every time, okay?